Okay, so we're going to be changing gears, literally and figuratively, and we'll be talking about the real source of demand, if you wish, the real cause of demand for energy, and that is the transportation sector, and particularly the people who drive every day and actually consume all that fuel. And part of our focus here is a problem that we see daily, that is traffic congestion and the associated environmental degradation and high fuel consumption that goes along with that. Now, congestion wastes fuel, okay? And that's why we're talking about it here. That's why when we look at energy demand and controlling that demand and curbing it, we have to look at how our system, in fact, is wasting fuel and wasting it big time. So congestion wastes fuel, and there's been various estimates of how much is actually wasted, that is, because of inefficiency in the operation of the system. Okay? So you're essentially throwing away, money and precious resources through the kind of scene that we experience and on a daily basis in our cities. Congestion is also highly nonlinear. If you look at the cost of delay, for instance, as a function of demand, you will, you will look in particular at this curve here. This is called a marginal cost curve. This is the extra cost that is imposed on society by each additional unit of demand. And you can see that this cost is really high and increases very sharply on the margin. That is, when we're already congested, every additional vehicle is in fact contributing in a nonlinear way to the total system cost. And this is true of delay, it's true of fuel consumed, and so on. So it's important to recognize that. It's also important because it tells us that any change we can have at the margin, even when it is small, will result in a significant improvement because this is the part of the curve that we're operating in. Congestion is also inefficient. If you look at our traffic systems and you look at the throughput as a function of density, you could see that as you're building up the density on the facility, vehicles are flowing, and you get up to what is viewed as nominal capacity of about 2,200 or anywhere between 2,000 and 2,200 vehicles per hour per lane. But as you build up, very quickly, you're going to have this breakdown phenomenon where through most of your peak period, you're in fact going to be operating somewhere between 1,200 to 1,400 vehicles per hour per lane, which is a very serious reduction. So you're effectively operating your system with a loss of nearly 30% during the time when you need it the most. And we have this every day, this breakdown phenomenon. And so as we talk about, again, reducing fuel consumption, these are phenomena that could be controlled, and that is a lot of the focus of the work that we do here at the Transportation Center, among other topics. Now, conventional view for dealing with these problems is that you can take various supply actions, that is, try to improve operations through flow management, traffic signals, ramp meters, adding capacity physically. These are all actions that normally will improve flow for us. And you also have a set of demand measures where you influence the demand for travel, particularly travel decisions of route, mode, departure time, decisions to participate in various activities, to telecommute, to change the trips, decisions to own more vehicles in a given household or to reduce reliance on the private automobile, location decisions, where to live relative to where one works, and so on. And that's been, so a lot of the field essentially has consisted of folks who try to improve traffic and then folks who try to improve behavior. But in reality, supply and demand interact very strongly in transportation, and both depend critically on the behavior of system users. And yes, this is who determines what happens in our transportation systems. And human behavior essentially is at the root of a lot of the system inefficiency that we experience, inefficiency in operation, inefficiency in fuel consumed, inefficiency of our delay time, and so on. And we know, traffic researchers know, that the cognitive and behavioral limitations of human drivers are at the root of system inefficiency. Phenomena such as perception time lags, reaction times, and a natural tendency towards overreaction under stressful situations or perceived risk result in volatility, congestion, instability, frustrating stop-and-go patterns, phantom bottlenecks. You know how many times you've driven in traffic and you think there is something blocking it, only to find that there really is nothing, and people are just not moving. You know, that's perception, time lags. That's what we're talking about. So there's many collective effects that take place in traffic, and a lot of these inefficiencies that we observe are rooted in behavioral and cognitive limitations. Similarly, if you look you look at travel decisions, you will find that behavioral considerations and attitudes of human drivers, households, and logistics managers are at the root of fuel inefficient patterns. Activity patterns and resource allocation decisions obviously reflect individual preferences and lifestyles, but these were acquired during a time when fuel supply concerns were minimal. People, lived in the suburbs, got the big homes, big cars, and so on. And it's convenient, it's comfortable, but fuel concerns were not particularly an important consideration. And as awareness increases of these issues, and we try to affect people's behavior, of course, we're facing some ingrained attitudes and preferences that need to be addressed. There's also different time frame for interventions and different impacts from short to medium to long run. But what is important and what I want to highlight is that small changes at the margin could have very meaningful impacts. And that's part of what I want to emphasize here. Now, behavior change is essential. What can one do? Travel less, travel more efficiently, travel green. I mean, this takes common sense to understand the kind of things that we have to do. But on the other hand, as transportation professionals, as traffic professionals, we need to try and operate the system in ways that are more efficient for its users and for our system. Now, there are three main tools that we typically consider that a lot of our research has focused on to influence that behavior. One is through controls, traffic, when you basically prevent people from doing certain things at intersections, at getting on freeways, and so on. But increasingly, we have a very powerful tool, which is real-time personalized information. And we're just at the very beginning of really recognizing the potential of what could be achieved with real-time personalized information. And another tool is dynamic pricing. Of course, you have all forms of pricing through taxation, cap and trade, carbon tax, and so on. But in the traffic context, in terms of affecting congestion, you can essentially charge for the use of facilities and do it dynamically in such a way as to operate the system more efficiently. And that has been also a major focus of our research here at Northwestern. You also have combined approaches where you use dynamic pricing with information, with traffic control, such as so-called hot lanes or value pricing and managed lanes, where you charge more for the use of freely flowing lanes, possibly, or facilities, while the free lanes are experiencing our everyday congestion that we're all familiar with. And these are facilitated by technologies for automatic toll collection, vehicle identification, and so on. Now, behavior change that we're interested in here, or what can facilitate it, is technology, particularly through intelligent management systems. And in this regard, there are two key realizations here. One is that you can eliminate or reduce individual human error, and the system will operate more efficiently. And as I said, that small changes in household and firm individual patterns could lead to significant gains in fuel-efficient, sustainable lifestyles. The second realization is by monitoring the state of the system at all times, it's possible to intervene and apply control actions in real time to best utilize available resources. And this applies, from the individual vehicle level to the traffic stream, to the entire network. The same logic of sensing, monitoring, predicting, acting, and implementing. Some technological drivers, there's five of them that I view as critical to what we can accomplish in the transportation realm. The first one is in your pocket. All of us have wonderful handsets, which effectively have become small communicating devices, computers, display, and so on. And what we can do with handsets is enormous and growing by the day, from navigation to commerce to social networking to purchasing and what have you. Some examples of innovative applications, there's a company called CitySense in the Boston area that is providing a social networking capability on your cell phone. Fortunately, I have videos that make these things move. I don't have them with me because it's not my machine. It's too complicated to link everything. But these can be used to study travel patterns. They can also be used to see where your friends are, essentially, which bars they're going to and what have you. And you have probe-based connected navigation systems where essentially people have given up on the government trying to provide the kind of infrastructure and information services. And you now have private and clubs, if you wish, that are emerging, where people are connected and they agree to report their information, essentially. So you have GPS navigation in your vehicle or that's handheld, and you agree that your information is going to be reported to some central entity that is then using that to estimate conditions, predict them, and then give information back to the members of the club, those who are opting in. There's some of these are beginning to emerge. They're relatively small scale, and the coverage is not large enough, but we're getting there. And with the entry of Microsoft into the what's called INRIX, which is one company that's providing that, and with the role that Google is playing in that space, you can expect a lot of developments. On the freight side and asset tracking, since 9/11, most sensitive shipments, of course, are tracked. But most large fleets are equipped with tracking devices, so you can know at all times where the trucks are located, can dispatch them, and operate your fleet more efficiently. Coupled with, again, technologies that were introduced for security applications but have implications for efficiency, such as electronic seals and readers at ports and so on. Putting all of these together, essentially, the internet with mobility, you get telemobility and telelogistics. That may entail changes in the nature of activities, of what people are doing, their location, interperson, interfirm interaction, and the process of activity generation and scheduling. Development number two are inexpensive wireless sensor networks. This is now giving us the view from the asset perspective, from the infrastructure perspective, and you combine the view from the particles themselves, the individuals, and the view of infrastructure or fixed assets, then you get a lot of real-time information. And again, a lot of the work that we're doing and areas where there's a lot of commonality between our agenda and that at Argonne's traffic analysis laboratory lies in developing the kind of methodologies for real-time decision-making given that kind of information. And here at Northwestern, we're working on again, real-time estimation and prediction software that can simulate large networks, estimate what is happening in the network, and then predict what will happen over the short term so as to generate control actions. And also to provide information to users. Okay? Talked about personalizing information. Well, there's been a lot of interest in, of course, what information can do. And what was seen is that, in the initial wave of looking at this problem, is that information can make things worse. Why? Because people can overreact. You give everybody the same information on what you have now. People will do the same thing, and that will create congestion on facilities that are even less prepared to handle that kind of traffic. And so we know that the solution to this is prediction. When you give information that is based on predicted conditions, not on prevailing sense conditions, but that poses certain challenges, namely trying to capture user responses to the provided information, the issue of consistency, the issue of reliability, and then computation for large networks. And that, again, is a specialty that Argonne, of course, is very well known for and an area of common interest for us. Another example where we've been very active is to do the same thing, to use prediction for pricing, to introduce prediction in the control loop so that from the sensed traffic world, we can go into our prediction tools, our simulation-based prediction tools, and then set the prices accordingly. And we have found that we can, in fact, eliminate this breakdown through that particular process. Development trend number 4 is developing decision support tools for fleet management and collaborative logistics. I won't say very much about that. And the 5th one, the area of peer-to-peer ad hoc networking. My colleague Fabian Bustamante here at Northwestern is one of the leaders really in this area, and it's one that holds a lot of potential for providing all of the benefits of connectivity among vehicles and really bypassing major investments in the physical infrastructure because the vehicles become the network. Of course, it's not all about vehicles, and a lot of what we're trying to do is get people to use more efficient means of transportation. That, of course, typically refers to public transit. So how do we get people to make the change from this to this? Okay? Those of you who are experts in marketing recognize that you do not have a winning proposition in trying to get behavior change. Okay? So we've been looking. What we need are more carrots, essentially, to induce behavior change rather than simply taxing or you cannot do this, you cannot do that, you cannot use your vehicle. You really need to give things that people are interested in getting. And we've been talking to a colleague in a new institute that's being set here at Northwestern, an institute for massive change that Bruce Ma will be leading. And we're talking about reinventing the transit experience. And one example of this is bus rapid transit. But imagine an enhanced environment coupled with personalized information and connectivity and, and pleasant surroundings that may, in fact, make it much more attractive for people to change their behavior. Now, our transportation center here, just a few closing words, our vision for it and our aspiration is to be a preeminent think tank and laboratory for cutting-edge transportation research that matters on a global scale. We want to be partners for all novel, high-impact research, and certainly Argonne is a leader in this area, and we look forward to interacting further in this regard. And we do seek to advance the state of practice through a mix of engaged application-driven research and fundamental advances. One of the major assets that we have and that we're proud of is our Business Advisory Committee, which includes all the major names in the transportation sector on the private side. And again, we seek to facilitate interconnections between theory, behavior, application, and models. And with that, I thank you for your attention.